Hello. Well, I bet you're all as fed up as I am with all this testing of waterproof boxes. It's driving me nuts. What I've decided to do, since this is only a test boat, is to use the Firebox box that I've already been using before with some slight modification for the test boat. And obviously we've got to research waterproof boxes and waterproof cable glands much more effectively for a real mission. What I've done is put the Lumberg connectors back in this box, but with hex nuts on so that I can do them up slightly more tightly. This one wasn't leaking, but this one was. So what I've done is I've got a slightly bigger O-ring which I put in here. Instead of 1mm diameter, this is 1.5mm. It's not a proper solution because the thicker O-ring doesn't really fit in there, but I'm hoping that it will be sufficiently thick to stop the leaking between the plastic and the metal of the socket. We also found that the plug that went in here, the Lumberg plug, was leaking through the cable seal. So what I've done with that is taken it apart, cut a bit of the cable off, re-soldered the whole thing and put some Hylamar around the cable before screwing up the back end of the cable plug, in the hope that that will fix that. So now what I'm going to do is just test it again, but I'm going to test it only with negative pressures rather than positive pressures. Right, so I've done the lid up, put the manifold on. I've just got to move the boat into the kitchen and plug it in there, and then we can apply a negative pressure inside. Well, here we are. I put the boat in the kitchen. Because these modern video cameras are totally useless on manual focusing, what I've done is I've put my Canon 5D Mark, whatever the hell it is, in manual focus on here, which I've focused down onto the interior of the box. And I've got a light up here. Don't know what more I can do, we'll see what happens. Right, well, it's underwater, and what I'm going to do is to apply a negative pressure to it, so the needle should go to the left. I'm going to put it up about to -0.2, which is about all I would think an IP68 box is able to survive. Is that -0.2? Not quite. I guess that's -0.2 bar. I don't actually see yet any water coming in there. Should we leave it there for a while and see what happens? I'll just change this focusing a bit. So I leave this, how long shall I leave this for? That's the question. Shall I move the light around so that maybe you can see things differently? Don't see anything coming through yet. Trouble is, this box is actually quite shiny, the plastic of it, so the bits of it that are shining under the light. But I don't think that's water. Don't see any sort of little droplets of water forming around anything. Ah, but of course the pressure has gone down again, hasn't it? The pressure's gone down now. That should not have happened, should it? I'll bring it back up to minus 0.2. So somebody tell me why that pressure is coming down. There must be a leak somewhere in the manifold. Well, unfortunately, water is now coming through. Where? Through that left-hand connector. I don't know if you can see that. Yeah, it's actually coming. I think incredibly that water is forming. Yes, it's actually coming through the seal. Or it's coming through between the black plastic insert and the metal, which means in effect that the rubber seal between this metal tube here and the socket is failing at this pressure on this one, the one on the left, not on the one on the right. Well, it's either that, or it could be that the water's coming through between the cable and the circular rubber thing that goes around it, and then making its way in that way, which is straightforward. That would be more consistent with what was happening last time, where we were getting bubbles coming out of here, weren't we, when we were blowing? So maybe that's what's happening. Which simply proves yet again that I cannot seal this rubber cable satisfactorily. Let's take the pressure off completely. Oh, actually, that's interesting that, see, at atmospheric pressure it's now reading positive, which it shouldn't be. This gauge is very unreliable, or rather its zero setting is unreliable. But that suggests that in fact maybe I was applying quite a large negative pressure, minus 0.4 bar perhaps, rather than, as I thought, minus 0.2. We could kind of assume that this will be all right in real life on a lake. On the plus side, using a thicker O-ring seemed to fix the problem on one of those connectors. And using only negative pressure inside the box did not leak round the lid seal. On the minus side, this cable, I cannot seal it to a cable plug, and probably can't seal it through a cable gland either, because it's the same technology. This cable is LAP, L-A-P-P, O-Flex Robust 210. It's a German cable, and it cost me £165 for 50 metres. I only wanted 10 metres of it, so I put the rest of it on eBay and nobody bought it. So if anybody wants a nice cable that's completely useless for fixing through cable glands, I've got plenty of it. This was the only cable I could find in the entire world that had at least 7 ways of a reasonable thickness, and which was UV resistant and marine resistant. So, I don't know. Back to the drawing board. But I suppose we made a little progress. Thanks for watching.